We can partition matrices in different ways to simplify solving different problems. So for example, we can partition matrix A into a left-hand matrix, a row vector, and so on. And the matrix can be partitioned in any way. Now, one thing we recognize is that partition matrices can help us visualize matrix multiplications using vectors. So remember that when we multiplied two matrices, we had the number of columns in A being equal to the number of rows in B, and our resulting matrix will have the same number of rows as A by the number of columns in B. So in matrix multiplication, we saw that we multiply the row in matrix A by the column in matrix B that corresponds to the entry in the resulting matrix. So if we wanted the resulting entry in row 1 and column 1 of the matrix, we multiply row 1 by column 1 of these two matrices. So given that this first entry is row 1 in A by column 1 in B, and this second entry is row 2 in A by column 1 in B, and this third entry here is row 3 in A by column 1 in B, then if we designate column 1 in B as the column vector B1, with the entries in the matrix B11, B21, and B31, then what we're essentially doing to get the entries in column 1 is multiplying this entire matrix A by this column vector B1. So that gives the entries in column 1 of the resulting matrix. And similarly, if we designate the entries in column 2 as a column vector B2, then multiplying the entire matrix by this column vector is going to give the entries in the next column of that matrix. And you can see a pattern here. So the matrix A by the column vector B3 will give the entries in the third column of the resulting matrix. So as we can see, this is the same thing as putting B1 to B3 in a row vector. So that's exactly the same as this matrix B, and we'll just multiply A by B. So really have a think about this. Now alternatively, we can designate the entries in A as row vectors. So we have the row vector in row 1 with the following entries. So if we multiply this row vector in A by column 1 in B, we get this entry in our resulting matrix. And multiplying this row vector in A by the second column of B gives this entry. And multiplying this row vector by the third column in B gives this entry over here. So essentially multiplying this row vector in the first row by the entire matrix B gives the entries in the first row of the matrix. And similarly, the row vector in row 2 of matrix A multiplied by this matrix B is going to give the entries in the second row. So here we're essentially getting row vectors representing each row of the resulting matrix. And similarly, the row vector in row 3 multiplied by the matrix B is going to give the entries in the third row of the resulting matrix. So essentially that's the same as representing matrix A as this column vector of row vectors and multiplying it by B, which is the same as multiplying matrix A with matrix B.